A very good evening, friends. And in the last video, what actually happened is somehow my uh, live stream got disconnected, and I had taught it a half live, right? And after that, things just stopped. So I'll just continue from half live today only, right? So as I said over here, okay, just let me take the pen. So half life is actually your yeah, great. So half life is actually your concentration of reactant is when it's halved is called the time that it reaches is called half life. So the time it takes for the concentration to get halved is called half life. Okay, so T half is our half life, and it is proportional. It is inversely proportional to our concentration to the power of n minus one. Okay, so this is it. So let me take the blue pen, and our first order rate is proportional to the first order of concentration. Second order is proportional to second order of concentration. Zeroth order is proportional to zeroth order of concentration, and so this is our equation for our first order. A is equals to A0 e to the power minus kt, and this equation t is equal to 2.303 by k log of a by a minus x. This is our second order equation. 1 by a minus 1 by a0 is equals to kt, and this is our zeroth order equation. A0 minus a is equal to kt. This is the derivation of it, so we don't need to do derivation of it, so it's fine. And I also said about the nth order equation. The nth order equation is an equation which will help you to find the like the rate equation for any order. So suppose it's an nth order equation where n is 0, 2, 3, 4. It can be 1 because n minus 1, 1 minus 1 is 0, which is infinity, so it cannot be that. So 1 minus 1 is 0, so 1 by 0 is infinity. Yeah. So kn is equals to 1 by n minus 1 into t, and in brackets we have 1 by a t to the power n minus 1 minus 1 by a0 to the power n minus 1. Right? Yeah, that's it. So suppose we are doing it for our second order. Suppose we have taken n is equals to 2. So this will be 1 by t. This will be 1 by a t minus 1 by a0. And this is actually a second order, right? If you just go back. See, this was a second order. 1 by a minus 1 by a0 equals to kt. And over here, what do we have? We have 1 by a t minus 1 by a0 is equals to kt. Right, so it matches. So this equation is right. Okay, great. So now, having said that, let us now do some problems. Okay, and so let us take a question. So question is this: if A is our what? A is our pre-exponential factor. If A is 1.6 10 to the power 12 per second, find K at high temperature. So at high T, at high temperature. So by Arrhenius equation, we know what K is equals to A e to the power minus E by RT. So our T is high. So like 1 by T, which is T is high. So this is like it can be said to 1 by infinity. So 1 by infinity is 0. So it can be said like 1 by E minus 0. So it can be said to be A. So K, so our K is equals to A, which is 1.6 10 to the power 12. So that was so easy, right? Okay. So now let us take another question. So question says K1 is equals to A e to the power minus E by RT. K2 is equals to A2 e to the power minus E, let this be E1, let this be E2, E2 by RT. Okay, so over here we have the answer. So it says this, find the relation between E1 and E2. E1 and E2, the relation. You have to find the relation. So we know, so what we do is we do K1 by K2. When we do this, what we get is A1 by A2, and we have e to the power minus E1 by e to the power minus E2. Right. The by RT part that we have, that actually gets cut, right? If we just bring this up, it will get cut. So we don't need to know that. So what we need is we have this E by E2 by E to the power E1. Okay. So now it is said to us we have to find the relation between E1 and E2. So and it is given. Okay, so it is given that E1 is more than E2. This is given. We have to find the relation between A1 and A2. Okay, great, great. So E1 and E2 relation is given. We need to find it between E1 and E2. Okay. So see, it is said that E1 is more than E2, right? So this part is more than this. That means our K1, K2 by K2. So suppose we just do it by like A2 and A1. If A2 by A1 is equals to, so let us just make A our subject. We have K2 e to the power E2, and downwards we have K1 e to the power E1. Okay, and it is said A. So this portion is more than this portion. Okay. So see, now what we can do is, okay, now, so the question is this, that we need to find relation between A1, A2 and K1 and K2. So the options were given in this form, like you have to find relation between A1, A2, K1, K2. So it's A1, A2, K1, K2. So now we know the denominator is high, right? So if we are to remove this part, if we remove this part, what will happen, right? The denominator was high in this, therefore this value was getting decreased, right? So now if we remove this part, this value will get increased, so this will have a more sign if we remove it. So it will be A2 by A1 is more than K2 by K1, right? So this is our answer, like this was in the options. Okay, so let us take another question now. Question is half-life or third order reaction. So we have to find this out, and it is given that 3C is giving you products. You have to take like C0 and C. So we know the rate order for the nth order reaction, right? The rate order for the nth order reaction is nothing but, you can say T. Okay, it was T is equals to 1 by K n minus 1, okay, into 1 by C to the power n minus 1 minus 1 by C0 to the power n minus 1. See, normally one way to remember this is that our value of C0 is more than C, because C0 is starting point and C0 is getting reduced, like it's getting reduced to C. So C0 minus C will be positive, or 1 by C minus 1 by C0 will be positive. So, and we need a positive value. Why? Because see, K and T are normal positive value, right? So that's a way to remember which comes before. So it's given like third order reaction is given half-life. Half-life means T half, and half-life means when your C is becoming C0 by K. By K, and third order N is 3, C0 by 2, N is 3 minus 1, 1 minus, okay, yeah. So C0 by 2. Okay. So this was C0 and minus 1. So this was 3 minus 1. Right. So we have 1 by 2k, and over here we will have your, this will go up. Okay, so this will be downwards, it will be c0 square, and this will be 1, this part. So the answer will be this. Okay, one mistake I made, this will be whole square. Okay, so be careful, let me just do it in a big portion, otherwise I'm making mistakes and I might get some dislikes. That is not good. So let me correct this part. Great. So yeah, now let us do it. So 1 by 2k, it is, so don't skip steps. Actually I also make mistakes when I skip steps, so it's better not to skip steps. Yeah, 1 by 2k, and over here we have c0 square. So this will be 4 minus 1, which is equal to 6. So this is the answer, right? Okay, let us see one more problem. Okay, so question is this, that a value is given, b value is given, and t half value is given. A value is 500, 500, 10, 20. So it's concentration values, like it's 10, 20, 500, 500. And t half values are given here, 60, 60, 60, 30. Great. Okay. Hmm. So now it is said we have to find the rate equation, and so we have to find exactly what is that, what is the order of A, what is the order of B. There's a trick of doing this question. The trick is this, that see, we have to see that see over here time is not changing. Okay, and in this portion time is changing, t half is changing, but in this portion b is not changing but a is changing. So we know that first order is has no relation with your t half. Why? Because t half is proportional to 1 by n minus 1. So 1 minus 1 is 0, so it has no relation with t half. So we see that t half is changing but b is not changing, so this has no relation. So b, we can just say it's first order by this. And if we don't like this method, we can also do it by another method, which is, see, what we can do is, just let us write the rate equation. Right? So let us write this like e to the power x to the power y. Okay, so order does not change, right? So we take two values which are same, as in, if we take these two values, these two are same. So what we can do, we can cut out A or we can cut out B. So let us cut out B. So let us take these two values, right? So, and in this case, T half is given. Okay. Okay. So this method would actually have been possible if the rate would have been given, but over here the rate is not given. The T half is given, and that makes the whole process very difficult, right? So but then we have to use this formula only for doing it. So let us see some more observations. See, when the time is halved, the concentration is doubled, right? So T half is getting halved, but the concentration is getting doubled. This is half, this is doubled. And so your what we can do right now over here. So see, if this implies that T half and A has a universal proportion, total universal proportion. Like if T half is half or A is, so it's something like this. Because when T half is half, A is double, so it's universal proportion. There's no like it's inverse to the square, nothing like that. So when do we get this form? When our n is equals to 2, right? Then we get 2 minus 1 now. So we can say that A is second order, B is first order, right? One more trick that we can use, okay, if you think this is like a bit too tough for you to figure it out, so one more trick which we can use is that take the two t half values, like t half 1, t half 2, okay, and so compare this with the two a values you have. So this will be like a1 because this is proportion is n minus 1. This is like a2 n minus 1, right? So it's like equal to, because we are taking both. Now what we do is, okay, so suppose we have as in these two cases what we had. Suppose in the last two cases only, like we have 60 and 30, 10 and 20. So we have 60, 30, we have 10 and 20. We have 10 and 20. This is like n minus 1. So this whole is n minus 1. Right? So the 6 minus 30 is 2. And this is like 2 to the power n minus 1. Right? If I didn't even make any mistake. No mistakes, right? So this comes out. So when will 2 to the power n minus 1 be equal to 2? When n is equal to 2. Because when n is equal to 2 to the power n minus 1, which is 2 to the power 2 minus 1 is equal to power 1 equals to 2. That's it. Now you're satisfied, I hope. Right? Okay, great. So now let us see some other things. Okay, I believe that the uh, I believe that the IIT JAM exam is next week, if I'm not wrong. Let me just check when is the IIT JAM exam, because I'm going to predict one question for IIT JAM right now, and whoever is watching will benefit. IIT JAM chemistry. Oh my goodness! It's on 14th Feb 2021. It's on your Valentine's Day. Wow, cool. The chemistry exam is from 3 p.m. to 6 p.m. Session 2. Cool, cool. Really cool. It's conducted by IISc. Very cool, very cool. Great stuff. I believe all of you will qualify in the IIT JAM exam. Okay. And now we will study about Michaelis-Menten equation. Michaelis-Menten equation is an enzyme-substrate reaction. So in enzyme and substrate biology, the main thing that we use is the Michaelis-Menten equation. And I believe there will be a question from Michaelis-Menten equation in your IIT JAM exam. This is my prophecy. My prophecy. Okay. Okay, so I think this here, Michaelis Menten equation. This is for your enzyme catalysis. Okay, so we have an enzyme and a substrate, an enzyme substrate reaction which gives us our product. So this is our K1, this is our K2, right? And this is our K minus 1. Okay, great. So our rate equation for this is will be K1 E is okay divided by these are concentration terms, right? K1 is rate constant divided by K minus 1. Okay, divided by actually Km plus S. Now this Km is a Michaelis Menten constant which is equals to K minus 1 plus K2 by K1. How to remember this value? It is very simple. Actually, K minus 1 is going this side, K2 is going this side, K1 is going this side. So the top is actually the one going away from ES, and the down is one which is going towards ES. That's how you remember it. And right, this part will be like K2, right? Because the rate equation depends on the last step, which is the main step. So this is called K2. Okay. Okay, so I'll take this class, this part in the next class. Okay, so I hope you enjoy this class, and in the next part I'll teach you about the advanced. This process is become an advanced part. So next part I'll teach you the advanced part of physical kinetics.